Good evening. In today's video lecture, we can see something regarding one of the example of Bayesian approach. Okay. In the last class, I had discussed regarding the Bayesian approach, and that we have calculated the values of theta cap or a cap, which is nothing but integral of theta into p of theta bar x d theta, or otherwise we can write it as expectation of theta of x. Now we can see the example of Bayesian approach. Okay, I will come across only one example. Example, that is DC level in white Gaussian noise. Okay, it's one of the very important question. I can call this as a Gaussian prior PDF. Gaussian prior PDF. Okay. So the observation are x of n equal to a plus w of n, where n equal to 0, 1, etc., comma n minus 1. W of n is white Gaussian noise. Value of a is to be estimated, or you have to estimate the values of a. Okay, and given that p of a is nothing but 1 by root of 2 pi sigma a square into e raised to minus 1 by 2 sigma a square into a minus mu a the whole square. Okay, a minus mu a the whole square. Clear? A minus mu a the whole square. So, okay, so W of n has a that also I will give you. W of n has a variance sigma square. Okay, W of n has a variance sigma square with the mean equal to 0. Okay, so you can see the solution for this one. Sorry. We have a cap is nothing but integral of a into p of a bar x into dA. Okay, or in general we can write it as a cap is nothing but expectation of or theta cap is nothing but expectation of theta of x. Okay, it's not, or a of x. Okay, so to find p of a of x, we use the relationship we use the relationship P of A bar x is nothing but P of x of A into P of A divided by integral P of x of A into P of A into D. So separately we have to calculate all this P of x of A, P of A, P of x of A into P of A into D. Okay, the integral of P of x of A into P of A into D. So we have P of x of A is nothing but that 1 by root of 2 pi sigma square square, or I write 1 by 2 pi sigma square whole raised to n by 2 into e raised to minus 1 by 2 sigma square sigma n equal to 0 to n minus 1 x of n minus a the whole square. I think you know that just now. So here P of A can be written as P of A is nothing but 1 by root of 2 pi sigma A square into e raised to minus 1 by 2 sigma A square what into A minus mu A the whole square. Okay. So that is P of A. P of x of A already P of A now we have to calculate P of A bar x. Okay, that is nothing but P of A bar x. P of A bar x is nothing but what is P of x bar A? 1 by 2 pi sigma square raised to n by 2 into e raised to minus 1 by 2 sigma square sigma n equal to 0 to n minus 1 x of n minus a the square divided by what you will get into one more term is this, I will into what is P of A. P of A is nothing but 1 by 2 pi root of 2 pi sigmas to 1 by root of 2 pi sigma A square e raised to minus 1 by 2 sigma A square A minus mu A the square. Okay, that divided by integral of x of A, that is 1 by 2 pi sigma square whole raised to n by 2 e raised to minus 1 by 2 sigma square sigma n equal to 0 to n minus 1 x of n minus a square into P of A, that is 1 by root of 2 pi sigma A square e raised to minus 1 by 2 sigma A square into A minus mu A the whole square dA. I think it's clear. So what I can do, inside the integral part 1 by 2 pi sigma square raised to n by 2 is common, 1 by 2 pi sigma A square is common. I will take that one outside. So what I can do, I can cancel this one, this two I will indicate with another link. Okay, I will cancel this one I will cancel this one, I will cancel this one, I will cancel this one. Clear? Because that are common terms, that I can reduce it. Okay. And what I can make? X square of n. Here x of n minus a, that I can make it as a minus b the whole square. Is now a minus b the whole square, a square minus 2ab plus b square. This term is nothing but, this is of the form a minus b the whole square. So a is here a square minus 2ab plus b square. In this term a square is nothing but x of n square, or x square of n minus 2 into x of n into b is nothing but a plus a square, like that it comes. So here x square of n is a common term, that I will take outside. Okay, that I can x square taken common from both numerator and denominator. I will take x of n common, and I will cancel that one. Okay, I will write here x square of n is taken common from both the numerator and denominator, from both numerator and denominator, and it can be cancelled. It can be cancelled. Okay, so I will just utilize that one, that is p of a bar x is now changes to e raised to minus 1 by 2 sigma square, 2 sigma square, but this term will be sigma n equal to 0 to n minus 1 what will be the term? A square, x of n, x square of n is common, that I cancelled, is 2a into x of n. It's not 2a into x of n. Sorry. Okay, 2a into x of n. 2a into x of n. Okay, what is the other term? Into e raised to minus 1 by 2 sigma a square, a minus mu a the whole square. Okay, divided by, you will have the term sigma integral of what? Normally this integral is from minus infinity to infinity. Okay, e raised to minus 1 by 2 sigma square, e raised to minus 1 by 2 sigma square, sigma n equal to 0 to n minus 1, a square minus 2a into x of n into e raised to minus 1 by 2 sigma a square, a minus mu a the whole square dA. Clear? So what I will do, I will take sigma inside the bracket, so it changes to e raised to minus 1 by 2 into 1 by 2. I will take in outside 1 by sigma square what a is in the first term you having a square minus 2a x of n. The second term is nothing but a minus mu a is not. So what I will do, I will bring one minute, just here is minus 1 by 2 sigma square mu a or na square is mu a or na, okay, both are same, plus, okay. So what I will do, I will bring sigma inside the bracket, so it will be n a square minus 2a x bar. Sigma n equal to 0 to n minus 1 x of n, that is 1 by 2 into sigma n equal to 0 to n minus 1 x of n is nothing but x bar mean. Okay, that is I will can write n into x bar. That's good. N into x bar. Okay, and the other term is plus 1 by sigma a square a minus mu a the whole square, okay, divided by, as it is, that is sigma minus infinity to infinity, normally e raised to minus 1 by 2 into 1 by sigma square na square minus 2a n x bar plus 1 by sigma a square by a square a minus mu a square into ba. Okay, the first term I can write it as e raised to minus 1 by 2 into q of a, which is nothing but e raised to minus 1 by 2 into q of a, because q of a is nothing but 1 by sigma square, the other terms, divided by c integral minus infinity to infinity e raised to minus 1 by 2 qa into ba. Okay, so this is the term. So where I can write qa where q of a is nothing but, what is the term, na square by sigma square, na square by sigma square minus 2 a n x bar by sigma square plus a square by sigma a square minus 2a mu a by sigma a square plus mu a square divided by sigma a square. Okay, this is something about qa. Okay, so in general I can write that one, e raised to minus 1 by 2 q of a divided by integral minus infinity in infinity e raised to minus 1 by 2 qa of dA. Okay, so I will write 2 points here. The first point what I can indicate is, first one, we note that argument is exponential or exponent, argument in exponent is quadratic, in A. Okay, the second point is the value of the denominator. The value of the denominator does not depend on a, and it act as a normalizing factor, for p of a bar x. Hence, p of a bar x must be a Gaussian PDF. Gaussian PDF whose mean and variance depends on a. Okay, this is the two argument that I can make from this. That is, we know that arguments in exponent is quadratic in a. Similarly, the value of the denominator does not depend on a, and it acts as a normalizing factor for p of a by x. Hence, p of a by x must be a Gaussian PDF whose mean and variance depends on a. Okay, so we have q of a is nothing but, I can write it as n by sigma square plus this term. Okay, I will take a square outside, plus 1 by sigma a square into a square. Okay, minus 2 into, I will write mu n x bar by sigma square plus mu a by sigma a square. One small problem. Anyway, we can try to do it. If there any mistake comes, means I will delete it. Okay, n x bar by sigma square plus mu a by sigma a square into a. This two term I take here. Last term, last term is nothing but plus mu a square by sigma a square. Okay, so this is something regarding QA. I can write in generalize as Q of A can be written as n by sigma square plus 1 by sigma a square. Okay, we write a square minus 2 into, because 2 into n x bar by sigma square plus mu a by sigma a square divided by what? Because I have taken n by sigma square plus 1 by sigma a square outside, so it will be this term is common, so I had to take the denominator. So denominator cancel, so you will get the this term. So what I had to do is n by sigma square plus 1 by sigma a square. I am not changing the equation. Okay, into, I have to make a into a plus mu a square by sigma a square. Okay, so I will take, let n by sigma square plus 1 by sigma a square is equal to 1 by sigma 1 square. I will take like that. Okay, and let mu n, sorry, n x bar by sigma square plus mu a by sigma a square divided by n by sigma square plus 1 by sigma a square. This term I will take it as mu 1. Okay, so the QA will be changes to Q of A is nothing but 1 by, the first term will be 1 by sigma 1 square a square minus 2 mu 1 a minus I will add and subtract the mu 1. Okay, plus mu 1 square minus mu 1 square, nothing has changed here. Okay, plus mu a square by sigma a square. Okay, so this thing, if I do this, means automatically this two will cancel, but I require this one, this term. Okay, that is why I write it like this: a square minus 2 mu 1 a plus mu 1 square minus mu 1 square. Okay, nothing has a small slight change in the mistake in the equation, but ultimate equation will be same only. Okay, so what I can write is QA can be written as 1 by sigma 1 square. This I can write a square minus 2 mu 1 a plus mu 1 square minus, I will take mu 1 square by sigma 1 outside the bracket plus mu a square by sigma a square. Okay, so that I changes to 1 by sigma 1 square a minus mu 1 square minus mu 1 square by sigma 1 square plus mu a square by sigma a square. Okay, so that in turn I can write it as e raised to minus 1 by 2 sigma 1 square, that is in our equation, a minus mu 1 square into e raised to minus 1 by 2 minus mu 1 by sigma 1 square plus mu a square by sigma a square. Okay, divided by the integral part, divided by integral minus infinity to infinity e raised to minus 1 by 2 sigma 1 square a minus mu 1 square a minus mu 1 square into e raised to minus 1 by 2 minus mu 1 square by sigma 1 square plus mu a square by sigma a square of dA. Clear? So this in change turns to P of A bar x. This is nothing but P of A bar x. This in turn changes to e raised to minus 1 by 2 sigma 1 square a minus mu 1 square. So this term I can cancel. Okay, divided by integral minus infinity to infinity e raised to minus 1 by 2 sigma 1 square a minus mu 1 square dA. Okay, because these two term are common terms, so this the numerator of this term and denominator this term I can take outside and I can delete that one. So that is common term. So you will have only e raised to minus 1 by 2 sigma 1 square a minus mu 1 square divided by integral minus infinity to infinity e raised to minus 1 by 2 sigma 1 square a minus mu 1 square of dA. So that I can change this as p of a bar x can be written as 1 by root of 2 pi sigma 1 square into e raised to minus 1 by 2 sigma 1 square a minus mu 1 square. Okay, that is nothing but p of a by x. 1 by root of 2 sigma 1 square e raised to minus 1 by 2 sigma 1 square a minus mu 1 the whole square. Okay, so I'll write some points. Since the denominator is independent, of a and act as a normalizing factor, for the PDF, that is p of a bar x, so that p of a bar x must integrate to 1. Thus, we observe that p of a bar x is a Gaussian. Therefore, I can write a cap is nothing but integral of p of a bar x, a into p of a bar x a into p of a bar x into dA, which is nothing but expectation of a of x, which is nothing but mu 1. Okay, since p of a bar x is Gaussian, Gaussian. Okay, so that I can write it as, which is nothing but mu x bar divided by n x bar divided by sigma square plus mu a by sigma a square divided by n by sigma 1 square sigma square plus 1 by sigma a square. Okay, so that is generally n x bar sigma a square plus mu a sigma square divided by sigma square sigma a square the whole divided by n sigma a square plus sigma square divided by sigma square sigma a square. Just I cross multiply with this one and this one, again this one and with this one. So what happens means I can delete these two terms. Okay, I can delete this term and this term, and ultimately what I will get? I will get which is equal to mu x bar sigma a square plus n x bar sigma a square plus mu a sigma square divided by divided by what? N sigma a square plus sigma square. Okay, sigma square, so that I can change it as n x bar sigma a square divided by n sigma a square plus sigma square plus mu a sigma square divided by n sigma a square plus sigma square. Okay, so that in turn changed as a cap is nothing but integral of a of p of x, p of a bar x of dA, which is nothing but n get cancel. Sorry, no, I can bring n outside, so n get cancel, so x bar sigma a square divided by sigma a square by sigma square by n plus mu a sigma square by sigma a square plus sigma square by n, because from here from this one from this one I take n outside. Okay, from here I take an n outside, so we'll have x bar sigma a square divided by, if I take n outside, it will be sigma a square plus sigma square by n. So this and this get cancelled, so this is something the same thing here, that is x bar sigma a square sigma a square plus sigma square. Similarly from this term also I take, from here I take n outside, that is na mu a sigma square divided by sigma a square plus sigma square by n, if I take n outside. Okay, clear? So this is a final estimated value, which is somewhat accurate value compared to that of any other type of estimator in case of Bayesian estimation. Okay, so I think you have understood this one. So just verify once more. Okay, the things what I have indicated here. So in the next video lecture we will come across with the general Bayesian estimators. Okay, thank you.